Hey, what's up, viewer? Welcome back to this Nebulous live development creation series. This is day 4, hour 2. It took me a little bit to get on to the next hour, but I'm finally getting on it here. I'm getting excited about what the game is going to look like. And over the last few days, I've never felt more confident about what I'm going to be doing making games. So I'm very happy to continue the series, and I'm very happy to continue leveraging this process of recording the development of this game as a way to help me focus in particular. And while I'm at it, I'm working towards better delivery and working on making sure I keep up my pace, and in general I recommend it, it helps. Alright, so I'm going to get started here. So last time I managed to make a couple tweaks to the scanning system. I have the radius of a scan determining, I guess not the radius of a scan. Okay, so the main thing that happened last time was I tweaked frequency. I changed the price. It scales exponentially as it goes up, which, if that's not clear to the player, at some point they need to understand that's how that works, but let's see what happens. And if I do a scan at the lowest frequency, a slow scan comes out. And there's actually an issue that I'm running into, which is I need to make sure the velocity of a scan that's that big versus this big is the same speed. So let's see. If I do a ring like this, I'm just going to count the ticks as seconds and run the scan, and we're going to see how many seconds it takes for it to reach the other side. So at 5, I'll do it. So it takes about 4 seconds. So if I do a scan of 1, it should not take 4 seconds for this ring to meet the edge. It should only take like 1 second. So let's see how this goes here. Okay, so there's something I've messed up here. A scan at 1 frequency at this range or at this range need to go the same speed. So that means a scan at this range, if it takes 5 seconds, at this range it should take 1 second. So I've discovered an issue with that in particular. And of course that has to do with the lerping. It's getting its velocity effectively from the distance divided by the time it takes. And the time it takes is, or more specifically, the iterator is scaled linearly through the frequency. So an equal frequency at separate ranges winds up with equal time, which was not what I intended. My intention was for the frequency to provide a consistent speed at any range. So I've got that a little backwards in how I've written the lerp, it sounds like and looks like. So I've got to fix that that's just so the game works correctly as anticipated, which is that red waves all have the same speed, or red waves of the same frequency all have the same speed. Therefore, I'm going to have to do some thinking on that one. The other thing I want to do is change the color of the wave depending on the frequency. So that would be red, and then like if it's a frequency of 2, this would be like orange, and then yellow, green, so on and so forth, or green, blue, and then indigo violet, more or less. And perhaps even make it to where it's like orange starts at 3, yellow starts at 5, so on and so forth. So what I'm going to have to decide on that one. But we will see. The slow scan is pretty cool in its own right. But changing the scan colors would be kind of cool looking. And then once the scan colors are changed, what was the third thing I was just thinking about? There's a third thing with the scan system. The fourth thing is like extra details on the scans or something. But the third one was, what was the third one? I have to admit, I've forgotten on the spot here. I just had it in my head and I forgot it. It was like... I can't remember, I'll think about it. But there's a third thing I need to fix as well to some extent. It has to do with the scanning system. Even though I have forgotten completely what it was. Oh, sorry, there might be some cats fighting or something soon. Over here. Okay, so... changing the frequency so changing the speed, changing the color, and then I can't remember what the third thing was. Oh, I remember now. Okay, so if let's say I do a scan, I'll just do it at max frequency since I can afford it, and I discover some entities. What would be cool is, let's say this frequency is at 1 or whatever. It would be cool if the scan would, upon collision with an entity, return a wave back to the planet. So like the wave would go out and then it would return basically a sonar ping, and it would give a graphical ping, and then ideally the player doesn't get like a data update until the return value comes back. And that's a thing in the game where like the frequency will return to the player. And it's one of those things that adds another element of reality to it, where the wave has to actually hit and reflect back to be detected, as opposed to just when the wave hits. And that will add a few other dynamics flying around in the game, which is kind of cool. And then if it scans something tiny with a big wave, it can even like return a scattered wave to signify that. It can get extra specific, but so that's what it was. That's a little bit more artsy though, and it doesn't actually help mechanically. It in fact is a secret nerf to scanning to a certain extent, because scans effectively all now take twice as long to register, basically. But it is a cool little dynamic that the player can... They basically happen... They're essentially effects from player cause. So the player's decisions contribute to those aesthetic effects. And it also makes sense where, like, once the scan gets back, then you get the data that updates in here. Or my idea was to have, like, maybe like a small little subpanel here that, like, comes up and it says, like, you know, new scan data. And then if there's, like, 2 or 3 of them, then it'll stack them, like, 2 or 3 new scan datas, and you can take a look. And it'll just give a quick readout of what returned. So you can see that there was, like, 2 planets and an asteroid or something. Or like sun, planet, asteroid, something like that. It's not fleshed out completely, but something to that degree. And then higher frequency scans would update their values once the scan returns as well. So it's kind of like an extra buff to higher frequency scans because the return is faster. So it's just kind of an interesting little dynamic to spruce up how the game works. But it's also not necessary. The first 2 options will quote-unquote fix the scanning. Or not fix the scanning, but the first 2 will be pretty good in their own right. Alright, so now that I've gibbered on about that for a while, I need to dive into the code, and I've got to figure out how to fix the lerp. First things. So let me set that up here. I'm going to go into the... Was it an active player scan, or was it active scan form? Okay, yep, this is it. So I've got to jump into this update loop, and basically this is incorrect. Because what's happening is it takes the exact same time regardless of scanning radius or iterator dynamic. So we need to go from 0 to scanning radius, but the iterator needs to okay, so this is where I'm going to grab my notepad and think about this with a little bit of conception, because I've got to tweak it around to get the math correct. Okay, so if I've got like a radius of 1, this should effectively, it should take 1 second at a frequency of 1, theoretically. That's what I'm going for here. And then a much larger circle, the radius of 5, needs to take 5 seconds. However, the rate of travel is 1 per second in either scenario. Yet in both cases, the lerp is this value, or these values here. In the iterator, so basically distance has to distance has got to increase the amount of iterations. And the way I'm seeing that at this point is perhaps dividing by the radius is the first thing that comes to mind, because if I divide by the radius, the iterator will go quote unquote, it'll take quote unquote 5 times as long to go 5 times as far, which is going to normalize the speed, I'm rather sure. And then that still gets multiplied by the scanning frequency. So, and then there is a frequency damper. So I think that's how I'm going to do it here. And if I'm fortunate, let's see, I should actually fix that pretty quickly here. And this helps to normalize the speed of travel. I need to make sure I don't mess this up here. Okay, I'm just going to make sure this works correctly by saying, it's telling me it doesn't matter. But I don't want to multiply the divisor. So I'm confused why it thinks it's not a big deal, but time delta time divided by player active scanning radius, that value is what has to multiply. We don't want to multiply the last 2 values by this and then divide time by delta time. Yeah, we don't do that. So I'm going to leave the parentheses then, even though it doesn't think it needs them. Because it has to do this division before it does any multiplications onto this. And, alright, let's see how this works. If this works, it'll be pretty easy to jump onto the shader graph for the... Or I might not even have to use shader graph to change the colors of the frequencies. Alright, so let's jump in here and do the test. And we'll max it out. Bump up the radius to we want to get it up to like 5 here. And I'm going to cheat my economy. Alright, so this should take 5 seconds. And it's taking a bazillion seconds. And I understand why that is, because it's because the damper is I'm actually starting to get a... Okay, so it's a fourth of as fast, but still. I didn't feel that... I guess it's going to be 5 times slower than typical. Okay, so I turned off the damper for a low frequency value here. So for however long this takes, let's see here. And now the frequency damper is 0, so it's multiplying by 0. So we'll just make it 1 then. Maximize this. Okay, now let's give it another shot here. Alright, so that was about 10 seconds. So now if I lower the radius to 5, it should definitely take 5 seconds. And it did take about 5 seconds. It looked like it took a little bit longer, but let's see here. So let's do one more test here. It looks like it's taking like a little bit longer, to be honest. That might just be because the radius is not at exactly 5. Oh, that's also true. It's that it's okay. Still, I think I fixed that. So this should take about 1 second. 1/1000. Takes a little. Feels like it takes just a little bit longer. It's almost like it goes from 0 to 1. Oh, and then it's not exactly 1, is it? So it was closer to 2. So how about this time? Okay. So it is. Okay, so I think it's fixed. As long as you don't understand that, because like just barely under 2 and this look the same, but they're not. So this and this take longer. Okay, but I fixed that problem. Very good. Alright, so now we just have to solve this problem of changing the color of the wave, which is really throwing me off because it's getting into some balance implications. I don't want to scale the wave if it's I can't use the max value divided by some number of colors as the range, because then the total range those colors represent will change. So they've got to stick to standard frequencies for the wave color. But that creates an issue where I then can no longer permanently max the frequency of the scans because I'll run out of colors. But for now, the goal is to just make it to where it will change on the visible light spectrum. Starting at 1 is red, and then every integer above that go up. So that winds up having a frequency of 1 to 8 in that regard, with 7 segments of this visible color spectrum in between. And then the floating points in between will mix the colors as necessary. And that effectively gives what? That gives 8 tiers of... That gives 8 scanning tiers, with the potential to push it above that using like X-ray and gamma ray. which I think there, and maybe there was one other way, ray, I can't remember, but I think there might be 2 or 3 non-visible frequencies that we can use anyway. And there's even theoretically visible light in the below red direction, but we're probably not gonna worry about that. So for now, what I'm going to do is I'm going to go to the wherever I go to set the default of, which I guess is in. I thought it was in player data. Was where I set that. Is it in UI data? I thought I had a value for that in here. So does that mean it's on my, is it on my planet prefab then? No, it is not. Where the heck did I put that? I was rather sure I had a value for, maybe it's on this. Okay. So to start, we're just going to lock the max frequency to 8, in fact. And it's going to go even lower eventually, because what we're going to do to start with is probably lock the player into a frequency range of 1 to 2. And then what they can do is invest in their tech to start bump it up the tiers. And then go to tiers 3 through 8, or 3 to like 10, or 11, or whatever we decide on. For now, I'm going to leave it at 1 to 8 so I can test the color ranges. And then eventually I have to change this to like, because the idea is that there's a couple of different ideas for how I want to proceed with this, but leave it at this for now. And I don't think it's hard code. Oh, you know what? I have to change something. Or wait, or do I? Okay, never mind. It looks like it's working. Okay, so now what I have to do is probably, well, I'm imagining doing it in a shader graph, but I'm also imagining doing it in a script. And just using a script to just change the instance color, because if I use the shader graph, it's going to change all of the material. I think it's going to change all of the material instances. So I have to change the colors of the held material, I'm rather sure, on spawn, based on the frequency, which I do believe is part of the player scanning. Or no, it's not that. It is actually active selection readout. No, it's not it. It's just active scanning elements. Okay. And when the button is pressed is when we have to make this decision. So we have the total economy minus. Oh no, that deactivates the button actually. Or wait a minute, this is confusing real quick. Wait, so did I really just wait, do I legit have 2 completely separate buttons here? No way. What the heck? It's the same button anyway. Okay, well that's cute. I accidentally messed that up. So this is actually an irrelevant declaration. And I probably should call it launch scan. I probably should. my cat will get out of the way here. I am actually going to change all of these to say launch scan. And then I'm going to run down here and we're going to remove this extra button declaration. And I liked having it down there so I could kind of keep it together, so maybe I will do that. Oh, but I use it in a bunch of places. Okay, so I guess it wouldn't matter. It's a C sharp. I think in C sharp I can do this. Or at least I thought I could. Okay, never mind, I can't do it. Whoops. Alright. So we'll just run like this. And I don't know how this is going to work because it's turning itself off while it's running an event. So we'll have to see if this breaks anything, but... So in the event, the cost of the scan is less than 0. So that's in the event I can't afford it. So that just guards it for if post scan I can't do another scan right after. Okay, so I guess that makes some sense. And here's where we're instantiating the player scan. Which means we are more or less going to just want to have a game object, new active scan like this. And then we have to say new active scan dot get component. And then I guess we have to say mesh renderer. And then we do not want to say shared material because that will change them all. So we just want to say material. And is there a material.color? There is. And then there's also a material.setColor, which I'm not sure if they are... Oh, that's in the material. Setting a color property. So I would understand then that this is just setting that color essentially anyway. So we're just going to set the color. And the color needs to be... It needs to be a certain number, doesn't it? And that number is... Let me think about it here. That number is going to be... More or less, it's like max frequency count. And then if you subtract 1, since it starts at 1, not 0, this value what am I trying to do here? I'm taking this value and I've got to divide it by, or it becomes a divisor for the color, the visible color range. Which is what, 255? Or it's technically 256. So you're breaking up 256 like this. And then you're essentially saying alright, so this is very interesting how this is going to play out because I could use a color to man, okay. So I'm actually not sure how to do this exactly because of the colors. Because I need to be able to, like, I have to scale certain channels basically conditionally, which feels extra complicated. I feel like it should be a little easier. So effectively, if I came here and was like equals color, or maybe a new color, (32-bit) represents RGBA colors. So a new one, it has to take in the RGB value, which means I'm gonna have to think about how to sequence all of these. But effectively, they're floats. So this gives the hold on. It's a little janky because I have to use the color numbers. So where was I? The idea was that, okay, so the frequency count needs to go from like 0 to 8, and 1 to 2, which is 0 to 1. Every 0 to 1 needs to fully change a color, which is usually by removing 256 or adding 256 of another color. So really quick, I'm going to open up, this is actually surprisingly more complicated than I was anticipating. Just getting it to freaking change its color here and there. Or it's not hard, it wouldn't be hard to just make it change to solid colors, but because I'm trying to make it go off of the float range, it's a little more complicated. So I'm going to open this up real fast and take a look at something. So if I open up this emission, in this event, we can go from 0 to 1 or 0 to 255. Okay, so red is max red. So red, and then orange is in fact like half of green. Red, orange, yellow. And then you remove red to bizarrely go into green. And then blue, indigo, violet. I guess this is indigo and this is blue. Man. So that's just a cipher. I mean, I'm just gonna have to decipher that more or less. So red is 25500. Well, I'm gonna write this down on my notepad. Orange is actually 255, or 255. It's half of 256, 128, so 255, 127. (255, 127.0). Yellow is all the way at just 255, 255. Green is in a funky spot where it's 0, 255, 0. Blue then is 0, 255, 255. Oh, but if I take away green all the way, it's indigo. I'm going to call that indigo blue because it's on pattern here. So we'll say blue is 0, 255, 255. And then indigo winds up being what we can call 0, 0, 255. Leaving more or less violet as 255, 0, 255. All right. So there might be some super smart way to solve this that I'm not aware of. For that, I apologize. But yeah, I'm doing it more I'm gonna have to do it more manually than that, and essentially say okay. So the key is that frequencies from 1 to 2 have a color of 255, 0 to 127, 0. Which means that more or less 0 to 255, which is 256, okay, so this is why, let me go back to that shader one more time. If it was in RBG01, I actually could just get away with using the distance from 1 to 2, or the distance from max range, min range to max range kind of thing, represents 0 to 1 every time, and that can change the color it's supposed to change. So we could say, so if I was to rewrite these over here, it would be like 1, 0, 0, and then this would be 1, 0.50. This is just 1, 1, 0. This is 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1. Magical. So this very simply explains which values are scalable, or which values have to scale depending on the starting tier, more or less. So I'm going to keep drawing it down here. Then we've got, so effectively we're going to change this then to say 1, 0 to 0.5, 0. And then 2 to 3 is 1, 0.5 to 1, 0. Whoops, spelled that a little wrong here. 3 to 4 goes okay, so this one's very interesting. This one goes from 1 to 0. 1, 0. And then 4 to 5 goes 0, 1, 0 to 1. 5 to 6. 0, 1 to 0, 1, 6 to 7. Wait a minute. That means I missed one. So red to orange. I guess I can write that over here like that. So it's the R to O. I guess I could do both. So let me write this here. Red to orange. Orange to yellow. Yellow to green. Green to blue. Blue to indigo. Indigo to violet. 1, 2, 3, 4, 5, 6. So there's actually only 6 ranges. So I am on the right one. So RO, Y, YG, G to B, B to I, and then I to V is 0, 1, 0, 1. 0 to 1, 0, 1. Okay, so I guess I'm just gonna have a huge switch statement or something for this. And essentially, depending on the switch statement, is going to affect the changeable range exclusively and reassign that color. Which means I've got to take another step here and it's always just 0 to 1, basically. Or it's, hold on, I'm going to figure out exactly how to do this. It's going to be it'll be different at every step, basically. Which is where a switch makes sense. So the value, or like this, the frequency, I should actually say, frequency. And then we'll see that the case is, so if case less than 2, for instance, it needs to run code that says material.color equals a new color, or I could even assign a new color, and then it's got to be and 0 at the beginning and the end with the middle button. It needs to go between 0 and 0.5, but each I know this is super simple. I know this is super simple. Essentially, it's 0 to 0.5 needs to represent like 1 to 2. And if the difference is then essentially what you're doing 0.5 to 1 is a ratio. Or, no, that's not correct, because then that'll double the value. I guess it's just 0.5 divided by 1. Or 0.5 divided by the value, which in this case is 1, which would yield so whatever the value is just is essentially halved. Or whatever the difference in the max and the min is. So basically it's just max minus min equals the value. And that just goes in to every other one, except for the first two, which have to be a little different. I still think that's a little off for the first two, because it has to shift for the second part. And it's essentially the same math, but it has to add a half every time. Is that correct? What is 0.5 divided by 0.5 is 1. Which means 0.5 divided by even less starts to approach it to 1 if I'm not mistaken. So 0.5 over 0.1, 0.01 almost shoots it up to 100, or almost shoots it up to. Now I'm stuck on. Which means that on the next step, you're just adding 0.5 to the result. Taking so long to figure this out, but it's just I know I've got to get the math correct here. It might actually work in the shader graph. There might be an easy way to do this by using a gradient thing, but then it's gonna like run all the time. So I think I feel like I'd rather just have it happen on the CPU. Okay, so min minus max is the full 1, which is the lowest of the value potential. And then as you approach the max value, you actually increase it, which is the same as saying, it's the same as doing that plus 0.5 in the second one. So I think it is, I think what I can do here is say, so if the frequency is smaller than 2, the new color is, okay, so I'm going to have to declare the okay, so technically so when the frequency rolls in, it has to subtract itself from the case number. So it would be like float something or other that's 2 minus frequency. And this number is in fact divided by 0.5 divided by this number. And that changes the color. And then the next step would be, so in the event of like case 3, case less than 3, oh, and this might go backwards because I might have to clamp the ranges in the case to be, I might have to clamp the ranges in the case, but however we do this, I'm just going to pseudocode it here still like this. So in the case where the frequency is less than 3 but greater than 2, you basically do the same thing. Float num is 3 minus the frequency, which is guaranteed to be, still guaranteed to be between 0 and 1 because the frequency has got to be greater than 2 to get to this point. And then you would say the new color is 1, and then you say parentheses 0.5 divided by frequency plus 0.5 is 0. And then the other cases, so for like cases 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, that's 6 cases total. The last 4 are much easier. You just say that the new color is this is, okay, so this has to be 1 minus the frequency. The frequency num 1, 0, and then this one is 0, 1, frequency num from 0 to 1, and then this one is 0, 1 minus num 1, and then this one is the frequency 0, 1. Okay. Let's see, the video's at dang 55 minutes, so I've got about 4 minutes. And let me see here if I can actually write this up really quick. I almost want to use this function, but I'm not going to. So it's got to do a few things here. It's got to say... So I'm going to do a switch case, which I'm... Okay, so we're switching to... player data... And I might have messed this part up, actually. Active frequency... Active scanning frequency. And the plan was to come in here and say case. Oops. So the idea was to come in here and say case. And I don't think I can go like this. I don't think I can. So in the event it's less than 3 but greater than 2, or actually it's 1, greater than or equal to 1, less than 3. And I don't actually think I can do this here. Yeah. Darn, so in the event that I alright, I guess I can't do case ranges like that. I'm gonna have to do the best thing I can imagine, in fact, is maybe mathf dot round up, or rounds to the nearest, round to int. Can I ceiling it? Can ceiling it. So the frequency ceilinged so the ceiling of the frequency is equivalent to 2. Which I guess I can't do this either. Darn. Alright, well I'm running up at the end here. I've got it mostly correct, but I'm screwing up the case. So this would actually work in a if block, which is why it's more or less... Okay, so I guess what I could say is this, actually. The switch is this. In the case... Oh, and is this returning a floating point? Okay, so then we can come in here then and just say case 2. Wait, I'm just gonna try case 2. Let's see if it works. And we come down here and say case 3. We basically just do the same thing multiple times here. So case 2, case 3, 4, 5, and the rest of them. Oh, there's only 6 total, isn't there? I keep forgetting that. So if the ceiling's at 2, ceiling's at 3, ceiling's at 4, ceiling's at 5, ceiling's at 6, or ceiling's at 7. Alright, so I'm at an hour for this video, but I'm going to start the next one right back up since I'm getting done with this particular code to change the wave colors very accurately. So thanks for watching the video up to this point. I'll see you in the next one.